Hello, everyone. Um, Today, what we're going to do are kind of some notes from the prerequisite chapter of the book. So, before chapter one, there's a chapter of prerequisite skills that you should have, vocabulary, things like that, that we're going to need to know as we move forward into chapter one. So, the two sections that we're going to focus on today and then next class after the quiz are going to be prerequisite section 3 and section 4. Section 3 is on polynomials. What's a polynomial? The vocabulary that goes with it. And then also some operations with polynomials. And then section 4 is about factoring. So what we'll do for the next two sections, we'll have those as videos. You're doing this video after finishing the daily quiz for today during some asynchronous time. And then the next video will be after your quiz that you have during next class. You'll do that also during asynchronous time. So we take a look at polynomials. The first thing we want to look at is just vocabulary. There's a lot of vocabulary with polynomials. So we'll start with the definition, and then we will look at a little bit of vocabulary that we use when we describe things later with polynomials, such as in behavior. It's important to understand the different vocabulary that goes with polynomials. So first of all, what is the definition of a polynomial? I mean, there's a very formal definition that you might see in textbooks in our book as well. But here's what I like to write. Just think of these simple things. So first, it's an expression, a mathematical expression with one or more terms. The coefficients of the expressions have to be real numbers. So the coefficients must be real numbers. So no i's yet. And the third is that the exponents on the variables are non-negative integers. So really, we're talking about the whole numbers there, right? 0, 1, 2, 3, dot, dot, dot. And it could go on forever. So you can't have an exponent that's a fraction, and you can't have exponents that are negative and consider it to also be a polynomial. So that's what it means for a mathematical expression to be a polynomial. So when we look at different polynomials, so for example, I'm going to put 3 different polynomials here on the screen. So we have f of x equals 4x cubed plus 2x squared plus 5. Then let's do, on the next one, let's do g of x is equal to 6x plus 5. And then the third one, let's just have h of x equal 5. So when we have polynomials, one of the things that we need to know is, first of all, what is the degree of the polynomial? So when we ask for the degree, what we're looking for is the largest exponent. So the degree of any polynomial is whatever that largest exponent is. So for instance, in our first polynomial, the largest exponent is 3, so this is considered to be a third degree polynomial. The second one, the largest exponent is 1, so that's considered to be a first degree polynomial. And then h of x, there's really an x here, but the exponent with it is a 0, because if you remember your properties of exponents, anything that goes to the 0 power is really 1. So this is really a 0 degree polynomial. Now, the other thing that we need to know about polynomials when we're talking about describing them in order to determine things about them at a later date is what's called the leading coefficient. So the leading coefficient of a polynomial is the coefficient that is with that variable with the largest exponent. So if I look at f of x, first of all, standard form means we're going to go with our exponents going from largest to smallest. So notice f of x is in standard form. The largest exponent is 3, so x to the third. So the coefficient that goes with the x to the third term is a 4. More importantly, what we're going to look at, it's not always the number, it's whether the leading coefficient is positive or negative. For g of x, the leading coefficient would then be 6. And for h of x, the leading coefficient would be 5. So in order to analyze polynomials, you've got to be able to determine the degree and the leading coefficient. And the only time this really gets tricky is, and it's not even tricky, it's that, people aren't paying that much attention. Like if I asked you, for example, to find the degree and leading coefficient of, let's say it's f of x equals 2x to the third minus 5x to the fourth plus x squared minus 1. So what people get in the bad habit of is they just look at, when they think leading term, they just look at the beginning. But what you always have to do is you have to find that largest exponent. Then everything that goes with that is, and the reason that's important is it's really when we get to graphing polynomials. Sorry, I didn't mean to erase that. When we graph polynomials, this term, the one I've just highlighted, the negative 5x to the fourth, is really what controls the major behavior of the graph. The other parts of this function are going to make some twists and turns and change it a little bit and change the shape slightly, but the negative 5x to the fourth is going to tell us what this graph is ultimately going to look like so that we can examine it. And so if we were to just do a quick analysis, the degree of this polynomial is 4, and the leading coefficient, I usually do this little abbreviation, L with a little c. The leading coefficient is negative 5. So leading coefficient, degree, and then what it means for something to be a polynomial. Those are the key vocab terms here for this section. Now, the next thing that we're going to do is operations with polynomials. So this is simply, what we do with a number. Any number we should be able to do with a polynomial. And what are the things that we can do with numbers arithmetically? We can add, subtract, multiply, and divide. Now, for now, we're going to focus on adding, subtracting, and multiplying. Dividing is its whole other thing, a whole other process that we'll have to go through later in the year when we divide polynomials. There is a process called long division, much like you do when you divide numbers in order to divide polynomials. But what we're going to talk about is just, if I want to take the polynomial 3x squared minus 4x to the third plus 2x, and I want to subtract x to the third plus 6x minus x squared minus 3. So I want to subtract those polynomials. So take a moment, pause the video. I'll come back with a solution. Okay, now these steps aren't always necessary, but just to show you kind of an easy way to do this so you don't get things confused, I'm going to go ahead and rewrite each polynomial in standard form. And so what that means is I'm just going to rewrite it where the largest exponent, that term, comes first, and then I go in descending order. And now I just have to combine like terms. So I have negative 4x cubed. Now we're subtracting. That's where also we have to be careful. So negative 4x cubed minus 1x cubed would be negative 5x cubed. Then we have 3x squared minus negative 1x squared. So that minus and negative becomes plus. So I've got plus 4x squared. Then I have 2x minus 6x. So that's negative 4x. And then we don't have a constant in the first polynomial, so we'll just call that 0. Minus negative 3 is plus 3. So there is our new polynomial. So we can add and subtract, and then multiplying. You've multiplied binomials for a while. So if we just start with a binomial, you've done this before. 2x minus 3 times 3x plus 1. Maybe you used an area model. Maybe you used the word FOIL. I just like to talk about distributing. So I'm going to take the 2x times the 3x, so that's 6x squared. the 2x times the 1 is 2x. Negative 3 times 3x is negative 9x. Negative 3 times 1 is negative 3. And so when I combine like terms, I get 6x squared minus 7x minus 3. So why don't we do one like this? So problem C, why don't you take 2x plus 1 to the third power and see what you would do with that. So pause it, try the problem, then come back and check in with the video. Okay, first thing you're gonna have to remember here is, what does 2x plus 1 to the third power mean? Well, it means 2x plus 1 times 2x plus 1 times 2x plus 1. And so what I'm going to do is just break this up really into two problems. First, I'm going to multiply the first two binomials. So 2x times 2x is 4x squared. 2x times 1 is 2x. 1 times 2x is 2x. 1 times 1 is 1. And then I saw this 2x plus 1 here. And now I have 4x squared plus 4x plus 1. And then I'm going to take that result times what's left. So now I've just got to distribute here. I have a total of 6 terms, right? I have 4x squared times 2x, so 8x to the third. 4x squared times 1 is 4x squared. Now 4x times 2x is 8x squared. 4x times 1 is 4x. And then 1 times 1 is 1. So there are, oh, I forgot the 1 times 2x. I'm going to say that's why I wanted to check. There should be 6 terms. I just had 5. I've got 1 times 2x is 2x, and then 1 times 1 is 1. So now when I combine like terms, we have 8x to the third plus 12x squared plus 6x plus 1. So that's multiplying. All right. Now, here is the last problem I want you to try. So I believe this is example 4. I'm going to give you some characteristics of a polynomial, and I want you to see if you can come up with the function that I'm thinking of. So here's your directions. Write a polynomial function such that these things are true. So first, the degree is 2. The leading coefficient is 5. The constant term is negative 6. And in your function, you know that f of 3 is 0. So what I would like you to do is use those 4 pieces of information and see if you can write a function, a polynomial function, that fits those characteristics. So again, pause the video, and I'll come back and go through it with you. Okay, let's take a look here. So what does this tell me? The degree is 2. That tells me I have a quadratic function with the leading coefficient is 5. So I'm going to start my function f of x equals, we know we have 5x squared. We have something times x. We don't know what that is yet. And the constant term. Constant term is your coefficient with no variable. That's negative 6. So I have a minus 6 there. So I'm really missing kind of what I have in the box here. I just don't know the coefficient that goes with x. But I do know this. I do know f of 3 is 4. And this is a really good review of function notation. Remember what this means is that when x is 3 on f of x, the y value is 0. So what I'm going to do is I'm going to plug 0 in for f of x, because that's y, and I'm going to plug 3 in for x. And I just have this blank to represent that little mystery value we're trying to find. You could use a different variable if you wanted. So here I have 45 plus 3 times that mystery value minus 6. So if I move things around here, I could see that I really have negative 39 equals 3 times that mystery value, which means that mystery coefficient ends up being negative 13. So that mystery coefficient ends up being negative 13. So our polynomial would be f of x is 5x squared minus 13x minus 6. So hopefully you find this section pretty straightforward, maybe not as complex as solving the rational equations, or definitely not as complex as the application problems that we've been doing. It really just is knowing some vocabulary and then being able to perform some operations with those polynomials. If you have any questions, feel free to get a hold of me. I'd be happy to explain things a little bit further. Otherwise, we'll talk to you again soon. Bye.